So hi, I'm Chase. I want to talk about the computational challenges that we face for teaching critical thinking at scale. And so for a moment, I want everybody to think about why do we not have MOOCs for critical thinking? Like, what's preventing us from doing that? We have MOOCs for all kinds of things. We have these huge, scalable classrooms full of students, full of different assignments, people learning all kinds of stuff, but there's nothing for critical thinking. Why is that? What prevents that? Well, I would make the argument that it comes down to assessments. If we think about the kinds of things that we can assess on MOOCs today, multiple choice questions, right? Those are easy, right? There's a right answer, right? Did they tick the right radio box, right? A+ or not, right? That's easy to evaluate. You can get a little bit more complicated. There are short answer questions, right? Fill in the blank, or where does the President of the United States live? The White House. You might also accept White House, right? So there's, okay, maybe a little bit of variation, but not really a whole lot, and it's still fairly easy to grade. There's a right answer, and there's a wrong answer, okay? For critical thinking, that's a lot harder to do. Now, sure, you might be able to break it down into a series of multiple choice questions or a series of short answer questions, right? But at a point, you're kind of leading the student too much. Right? If you want to assess their ability to, here's a situation and it's completely uncertain. If you start guiding them toward, think about this issue, think about this issue, think about this issue. Now you're leading them down maybe the right path, which is maybe fine at the very beginning. But if you want to really know, can they be in a situation in a clinic where they have no idea what's going on? Can they really put together the right thought process? The assignment kind of has to be more complex than just something that's short answer or just something that's multiple choice. So these assignments that we've been using, previously used the platform ALP, now we're using Scholar, but these assignments are more complicated. You saw that they're very rich. There's all kinds of information in there. There are test results. There are relevant passages from the case description. They're incorporating outside resources, references, right? So these are complicated assignments that try to demonstrate a thought process. That's a lot harder to grade. Okay, so the computational challenge here is how do you do that? How do you grade something like that at scale? Okay, so sort of traditionally what we've been doing right now is you have some submitted assignments and then Duncan spends 3 weeks trying to get through them all. And then you have your final grades based on the result of that. That takes a lot of time. And furthermore, this typically has to be an expert. Right? I can't put a novice there because the novice isn't going to provide the right assessment. Right? It has to be somebody who's been trained to do this. So even if it's a TA, you have to train the TA to know exactly how to evaluate these things. Right? So that's very, very expensive, very, very slow. Obviously, if it's tough for us to do with 100 students, it's impossible for us to do with 1,000 students, and completely unthinkable for 10,000. So how do we break that? I'm not proposing to put the TAs out of work. I'm not proposing that you will never grade anything ever again. However, what I'm trying to propose is something where you are working together with the machine. Okay, so how do we create a collaboration between the machine learning tools that are doing these automated assessments in some form with the instructor and the TAs that are doing manual grading? What does that look like? What's the right collaboration here? Right, how do we make most effective use of your time while you're doing that grading? Right? Obviously, this is 100% of the effort to grade all of the assignments. Can we get that down from 100%? Can we have some collaboration that reduces the amount of effort you have to spend to actually grade these kinds of assignments? So we've done some work here, and these are sort of the research questions that we're interested in. First is feasibility. So how effective are state-of-the-art machine learning approaches for automated grading? So there's all kinds of machine learning tools that I'm familiar with from my CS background, right? How applicable are they? Can I use them right now? How well do they do? So that's feasibility. Is this even possible to do with standard state-of-the-art tools? The second is formulation and evaluation. So this is from my perspective, from the evaluation, from designing an automated tools perspective. So formulation being, how do I formulate the grading problem? What's the right way to think about that? Evaluation being, suppose I had an automated system that was assisting someone in assigning grades. How do I evaluate? What's the right way to do this? It's actually maybe more interesting than just trying to predict grades. We'll get there. And then integration. What is the right form that this should take? What does the system look like What do you actually see? What are you doing? What are the actions that you're taking to guide the machine? How is the machine guiding you? Right? What does this look like? What are the trade-offs? So we looked a little bit at some of these. So first, just to assess, is this even feasible at all? We took a standard, off-the-shelf tool for doing what's called ordinal regression, which is basically trying to predict these Likert scale-looking rubrics, right? 1 to 5, novice to expert, right? So we're trying to predict what the rubric dimension, the quality that you'd assign to a particular rubric dimension, and there are 6 of these. So here is just one particular one, and I'm a CS guy, of course I had to have some math here, right? So this is just a fancy way of saying what's the average absolute difference between what the system said and what you would say, right? And so this was the machine learning tool. This was a stupid baseline that just said, everybody gets a 3, right? Because 3 happens to be the most common thing for this particular dimension we analyzed. So it would give you a nice looking result here because it's not wrong very often because the grades are normally distributed, right? But it's completely useless for evaluation because everybody got a 3. So it doesn't tell you who's the expert, who are the people who need more help, right? So this is a useless but useful baseline to compare against. So in this particular dimension, I believe this was quality of argument. We do statistically significantly better than this just naive baseline. So we connected. It is actually possible. It depends a bit on what features you're using. So how do you represent the assignments? What's the input to the algorithm? But the takeaway point from this slide is basically that it's possible for this rubric dimension. If we look at something else, it's not so clear now. Right? For clarity, using the features that we picked, obviously, it's bouncing back and forth between the two approaches. It's not really working. So the main takeaway here is that effectiveness for just off-the-shelf tools for just, I have some data, I want to apply it to this particular rubric dimension, really, really depends on the rubric dimension and what features you're using to represent the assignment. So if the features can describe the kinds of things that a grader would be looking for evaluating that rubric dimension, maybe you're fine. But here it's clear that the features that I was using somehow do not describe the clarity of the argument, which sort of makes sense. I didn't look at things like trying to classify what the flow of the argument was, right? I didn't look at flow features or something. I just looked at local, what test results did they give me? What particularly did they say to describe these things? What fraction of the test results that they picked were actually picked by Duncan, right? So this is so the features I use probably aren't applicable for this particular rubric dimension. So we have to think a little bit more carefully about that. But it's possible for certain dimensions. But is outright grade prediction really our goal? I would argue it's maybe not. So what about annotator agreement? So annotator agreement being if you have 2 different people grade the same assignment, do they agree, right? This is low in practice, even for short answer questions. It was found, there was a study that they were doing short answer grading, and even instructors, there was 2 different instructors, they disagreed by at least 1 point more than 44% of the time. That's a little bit rough, right? If it's rough to get us to agree, it's going to be harder to get a machine to agree with us when we can't get our peers to agree with us, right? So maybe this is not the right thing. And this is only going to get worse as we have more complicated assignments. If they can't agree on a short 3-word phrase, whether that's a 3 or a 4, right? It's going to be even harder when you have a complicated medical case analysis, right? That's just going to exacerbate this issue. And there's a significant barrier here to leveraging peer grading, right? We saw there's, it's not, Duncan had a wonderful plot for this, so I don't need to belabor it too much, but right, you saw the peer reviews weren't consistent with Duncan's evaluations. So maybe you can fix this with calibrated peer grading, and there's lots of results here that you could maybe apply, but the point is it's not immediately obvious. It's not easy. You have to think very, very carefully about how you're going to adjust the peer scores to try and line up more with what your scores are. It's not just, oh, I can take the average of the 3 peer scores and that's it, I don't have to think about grading, right? That doesn't work that way. And the machine will always be imperfect. It's never going to be perfect. It's always going to make mistakes, right? It's unrealistic to expect that we can come up with something that's this perfect grader and it will never make any mistakes, everyone's infallible. It's always going to screw up. The question is, how sensitive is it? When it screws up, how badly does it screw up? how badly does it hurt us when it makes a mistake? If we're trying to outright predict the score, if it grades a 3, a 4, that hurts. Right? If it grades a 3, a 5, that really hurts. Right? So it's very sensitive to just, even if it's just a 1 off, a 4 versus a 5, grading a 4 as a 5, that's wrong. Right? That person was not an expert. That makes a big difference. So even small little changes in what the system's output is really hurts us in terms of using these to actually grade people. So is there a way to reduce this? Right? Can we think about the problem differently to reduce that sensitivity so that if the machine makes some mistakes, it's okay, right? It's still, on the grand scheme of things, is not that bad. Okay, so how do we reduce that sensitivity? So I would argue that we should actually be thinking about this from a computational perspective as a ranking problem. And I'll argue for that based on the 2 problems that I just talked about, right? Annotator agreement. It's a lot easier to get people to agree, is A better than B? Than it is to say, on a scale from 1 to 5, how good is A? And then a little bit later, okay, here's B. On a scale from 1 to 5, how good is B? It's very, very, very hard to get people to agree on that. And this has been shown in all kinds of different domains. In my domain, it's been shown for evaluating machine translation systems. So here's a foreign sentence. Here's a particular translation for it. What is the quality of this translation? What is the faithfulness of this translation? Give me a score from 1 to 5. People don't agree. They don't agree. So they switched to doing, okay, here's a foreign sentence. Here are 4 machine-generated translations. Here is a professional translator's translation. Now rank them. Tell me which one is better. Put them in order. Right? So this one was the best, this was second best, this was third best, this was fourth best. A lot easier to get people to agree when you do that. Okay? Because now you're doing comparative judgments rather than trying to think, okay, what did I call that other one? I called that one a 2, so I guess this one needs to be a 3 or maybe a 2.5. It's much harder to try and do that. It's much easier to say, okay, here's this one, look at them, which one looks better? Well, this one kind of screws up there, this one kind of screws up there. I value this mistake higher than that mistake, so this one's better than this one, even though they both made mistakes. It's easier to get people to agree in these pairwise. And it also provides a much easier mechanism for leveraging peer review. Right, we saw that one of the problems with peer review is that they're kind of systematically biased positively, because everybody's great, right? That positivity, that bias towards assigning higher grades doesn't necessarily carry over to a judgment where, is this one better than this one? Right? Even if Duncan calls A a 3 and B a 2, if I, as a student, would grade the 3 as a 4 and the 2 as a 3, I'd still rate one better than the other, right? Even with that bias. So it corrects for some of that bias. It's not going to be perfect, but it corrects for some of that. And now there's a nice way to incorporate that into an algorithm like this. I can leverage peer assessments, which ones were better than others. I can leverage instructor assessments, which ones are better than others, and weight the instructor assessments higher, trust those more, model how confident I feel about the peer assessments, and now that gives me a nice, easy way to incorporate that into a system like this. Whereas before, if you can't trust the output of the students in the rubrics, you can't really learn a machine learning algorithm from that. But if you can trust these pairwise judgments easier, then it's a lot easier to incorporate that knowledge. So the machine will still always be imperfect. It's still going to mess up. It's still not going to give you the right ranking. If the output is, here are the students from best to worst, there's the assignments, the machine isn't going to give you the same ranking that you would. It never will. It'll always make mistakes. However, now, if I rank, the number 2 position is number 3, and the number 3 position is number 2, probably doesn't matter so much. It's not going to hurt very much. The way that I would do grading in this model would be to go through this list, assign a cutoff at a different point, like, okay, everybody above these were probably the experts. Somewhere in here, these are probably the proficients. Somewhere in here, these are I forget what 3s are, and here are the advanced beginner, and here are the novices, right? So it's just a matter of kind of finding these cutoff points, and if things are a little bit permuted within those cutoff points, it's fine. It doesn't hurt us that much. Now, sure, if somebody's permuted on a boundary, yeah, it hurt, but it's much less sensitive to those kinds of mistakes, than outright predicting the grade level. And now, grading is just assigning those cutoffs, and that's kind of natural. That's what you do when you assign final grades, right? That's kind of nice. But now we need a different evaluation metric. Before it was how far off were we on assigning an actual grade point value. We're not assigning a grade point value, we're putting them in order. So now we need to have a different metric, and this is just a particular metric. I won't go into the details, but basically this is a distance measure between how you would rank the students and how the system ranked the students. So it's trying to measure stuff like how many pairs are permuted in the wrong order and how far off are they, and that sort of stuff. And so I looked into this, and then there's this other question of, is batch mode machine learning the right setup? So in that feasibility study, the way we set that up was, we said, okay, we're going to have 50% of the assignments be graded, and then we're going to try and grade the remaining 50% that aren't graded. But that's kind of not really realistic. It's not collaborative, first and foremost, right? So I talked at the beginning of this, right? Our goal is to have the machine helping the instructor, trying to use the least amount of effort to get these assignments graded. Having you grade at a random 50% and then throwing that at the machine and having it churn and say, here are the outputs, wasn't really collaborative. The machine had no opportunity to tell you, oh, don't grade that one, I already know about that. I already know what I'm going to grade that one. I'm very confident about that. Don't worry about that one. Grade this one instead. I have no idea what this one's going to be. Can you grade this one instead? Right? So batch mode learning is probably not the right way for this, because there's no opportunity for the system to ask you specifically this assignment. I think that one's going to help me the most. And there's also this question of the stopping decision. How many, is it 50%? Is it 25%? Is it 30%? If I have currently graded 30%, should I stop? Should I keep going? I don't really know. It's hard, right? It's hard to know when I should stop. So the alternative is active learning. No, not that active learning. Okay, this is active learning from a machine learning perspective, from a computer science perspective. And the setup for active learning is this. So you start off with some small labeled examples, whether those are actual ordinal grades for assignments or whether those are A is better than B judgments. Okay? Given the machine churns, produces a model, and then figures out, okay, among all of these data points, all these assignments, or all these pairs of assignments, which one am I least confident about? Which one does the machine not really know? Give that one to the instructor. Now you really know. Now you can figure out, okay, why was I uncertain? What parts of the model do I need to adjust to make it so that that one gets the right judgment? Right? And then you go back to one until you're satisfied with the output. So every step, the machine will say, please grade this one. And then it'll churn and say, please grade this one. Churn, please grade this one. And at every point, that churn process is producing a ranking, which you can click in and look at a couple different values, a couple different places, and see if you're satisfied with it. And if you're not, keep going, right, until you've achieved some reasonable ranking. Okay, so this provides a much natural stopping criteria for instructors. And this is obviously collaborative by design, right? The whole setup is specifically tailored for the machine being able to ask you specifically for what's the most useful assignment to grade next. And if you do this, here is what you'd get if it's just at every step, just randomly pick an assignment. Please grade this random assignment. I have no idea. The machine is not helping you at all. The blue is the active learning setup. So at every step, the machine is saying, okay, this pair is the one I'm least confident about. Please grade this pair. Please tell me whether A is better than B. Right? And you can see that for the same amount of human effort, doing the active learning is approaching a better solution more quickly, right? This is a distance measure, so you want that to be 0. 0 would be there's no difference between the system output and your output, right? So using active learning drives this down significantly faster. Okay, so I would argue that maybe the way we ought to think about this is certainly we should be using active learning. That's the right setup. I also think that using a ranking approach is probably also better for being able to incorporate the peer reviews as well as the instructor reviews for dealing with this issue of annotator agreement not necessarily being very high for grading complex assignments. And it's clear that there's promise here. Okay, so that's stuff we've done, and this is the directions we're going. So I talked a lot about this. How do we incorporate peer evaluations? Scholar is providing an excellent platform for gathering all of this peer review data. How do we shovel that into the machine learning algorithm here to help us automatically assess things, or help assist us in assessing these things? It's not necessarily going to do the work for you, but it helps you do it. This should reduce the amount of effort we have to spend, but what's the right balance? How do I deal with a student who just gives everybody 5s? How do I learn not to trust that student?
How do I deal with the student who's a curmudgeon and gives everybody ones? How do I learn not to trust that student? How do I adjust for the quality of the evaluations that the students are giving? How do I learn how confident I am in them? This is a challenge. And what I've talked about here is automated assessment. What's more important than automated assessment is automated feedback. Feedback feeds into learning. I just give you, here's your score. Why? Why did I get a 3? Right? If I don't provide that, I have no ability to adjust for that. The peer evaluation helps with that, but we also would like to have some way of incorporating a tool like this, which is learning from also expert judgments, to help automatically give students some feedback before actually going in and looking at the assignments and providing detailed comments. If we can at least give them a high-level overview, these are maybe the things you did wrong, that's helpful. So we want to look into this.